China is taking over. The world of batteries interests me. I mean, it goes with the name, doesn't it? Battery Man. And things are moving quickly each year. So, where do you turn to know how things are progressing? The Volta Annual Report, a detailed document explaining the battery industry, what's happening, how it's happening, where it's happening, and what we're likely to see in the future, is the go-to place. And yes, I've read a 562-page slideshow to answer those questions. And if you want to know, you haven't got to read through that document, you could just watch this video. So let's kick off. And there's two big things that stand out to me in the battery world over the past year. And the first one is over there. Okay. Yeah, so China. China dominates the battery industry. And it's no surprise with their ferocious appetite for energy as they continue to develop their economy. Europe and America have done an amazing job of helping them to refine their manufacturing processes by giving them plenty of work over the past 20 years, hey? Now, it almost sounds stupid for me to say this, but China is the go-to place for batteries for both electric vehicles and energy storage. EVs and BES, battery energy storage systems. We'll use those acronyms from now on. China is opening factories all around the world. Now, this isn't to say that the rest of the world has been sitting and doing nothing, but it's clear that China is the king of battery production, largely fueled by their massive uptake in electric transport and their ferocious need for energy with growing populations and increased manufacturing in general. Okay, so let's back that up with some actual facts. So the 2024 report by the Volta Foundation shows China's dominance. It really does feel like it's China against the world with batteries. What's even more impressive is that China doesn't have all the resources it needs to make these batteries. They have a massive control over the supply chain, which helps them to bring prices down. Now, this has actually resulted in two things. One, there's an overproduction in batteries in China, which is pushing some of the smaller players out of the market. In fact, it's making it more difficult for America and Europe to compete with China. And two, that's led to China expanding out of China itself and producing batteries in other markets for those markets. This feels like quite a good position for you and me. Lower battery production costs means that our EVs and BES, home energy storage, should become more affordable over time. And we've seen this, haven't we? We've seen the costs come down, but how on earth are manufacturers doing this? Well, for one, there is that overproduction in China. China is producing batteries on a massive scale with more and more gigafactories. America and Europe are also producing more gigafactories than ever before, ramping up productions. But it's not just scale. By refining the supply chain and the actual manufacturing process, we've all benefited from the reduced battery prices. Now, battery production itself is fascinating, and it's all about producing as many batteries of the highest quality in the shortest time. Now, this is a challenge, and over time, efficiencies in these processes have been improved. It all reminds me of the newspaper printing production lines, or stoking the Titanic. Nothing stops the process, it's continual. But let's just say that the Titanic discovered the JCB with the special coal attachment bucket that could lift a ton of coal and place it exactly where it needed to go in the furnace, in the same time that one man could shovel one shovel's worth of coal into that furnace. So, how exactly do battery manufacturers shovel coal in as it were. Now, before we move on, I discovered in this report that petroleum products were actually researched back in 1985 as part of the battery anode material. It kind of feels like that study was sponsored by the oil industry. And believe it or not, petroleum coke was used for a while until graphite replaced it. Sorry, oil industry. Okay, so shoveling coal, efficient battery manufacturing. You've got your raw materials. They come in, then your coatings are mixed and spread very thinly onto the base material. A little bit like Marmite on toast. Anyway, I'm hungry. This makes its way onto cylindrical cells, prismatic or pouch cells. All of these steps have the possibility for some errors in manufacturing, but how do you spot them? This is where technology has drastically improved over time. We have X-ray, ultrasound, infrared cameras that are able to detect and reject faulty batteries or cells before they turn into batteries. All of this requires humongous amounts of data. I almost couldn't believe how much data was required for each production line, with some of that data being kept for compliance for a long time. So data is detecting errors, then AI is refining processes to ensure that mistakes are learned from. Reducing waste of the materials reduces the final battery cost. But it is so much more than wastage. Raw material costs have come down, and production lines have become more productive. Like any industry, as it develops, it finds new ways to cut costs while also increasing productivity, and that is certainly true of the battery industry. The battery industry has needed to cut costs for suppliers and manufacturers to survive. But I just want to focus on the automation side of things. Automation reduces labour hours and increases the productivity, while potentially providing us, you and I, with a better product. You see, the manufacturing of batteries is a multi-step process. Despite all of the production enhancements, the Volta report suggests that the price of batteries actually has further to fall, despite being at an all-time low. The report highlighted how battery production overall has increased in the last year, resulting in 1.5 terawatt hours of battery production in 2024. I can't quite get my head around that figure. So what exactly is involved in making batteries? Well, you have your raw ingredients that are mixed up into pastes for both the anode and the cathode. Then they're coated and dried onto the current collector. This step alone accounts for 54% of the cost of the electrode production. We then move on to calendering, where electrodes are densified to their target value, followed by slitting and notching, where electrodes are cut into segments, including cutting away non-coated areas. Then we have vacuum drying, a process which takes 12 to 24 hours for the solvents used in production to be removed. At this stage, we have the base material to turn into a cell. The next steps will depend on whether that cell is a prismatic cell, cylindrical, or pouch. So let's consider pouch cells. There's a reason for later on. Tabs are welded, pouches are formed, layers are stacked and laminated, then a defined amount of electrolyte is injected into the pouch. Now, at this stage, a seal is made to hold that electrolyte in. There are so many different steps if you really wanted to break this down, but just consider some of the challenges. That electrolyte that is put into that cell, you got to put the right amount in and you have to seal that up. That seal has to last for the entire life of the battery. You don't want a splodge of electrolyte to get trapped in between that seal as you make it and end up ruining the battery further down the line. It just highlights how many steps there are and how they all need to be perfect. Then our cell goes through its initial charging and discharging to electrochemically activate it. This is a slow process and is actually the one where we risk fire if we were to have fire issues. Then our battery sits to age in a specific temperature and humidity. For pouch cells, gases that are produced in the process are then cut off in a vacuum chamber with the final charging and discharging and aging process. You can see how the whole section is a lot slower than some of the previous sections we talked about. Before the pouch moves on, it needs to be checked under quality control to make sure that it has the correct resistance, capacity and voltage. Now, one cell on its own isn't going to do a lot for us. Cells are connected up to form a battery, which involves welding tabs and matching cells up. These are then modularized and then moved onto a pack assembly. We're starting to get into some big heavy weights here, so machinery tends to get involved in the lifting, and of course the voltage is going up, so this adds another level of safety concern. Of course, while all of these cells together could output power, they'll not work safely like this. So the next stage, we need to apply a BMS, adding a number of controls including temperature sensors, voltage feedback for cells, all fed to the battery management system or the management brain. With our pack built and ready to go in the vehicle, it needs to go through a final test to ensure the highest quality. This includes, you've guessed it, a charge and discharge cycle test. The tests at this stage can vary from manufacturer to manufacturer. Now, earlier we touched on some of the data that's involved in producing a battery. All of this because each of the steps that we've talked about before have the opportunity for different types of sensors, different types of scanning to spot issues real time. Now here are just some of the tools that are used and some of their applications. Did you realise how high-tech the battery manufacturing industry is? Let me know in the comments below. The report went into some detail on how these different systems work to spot particular types of defect, but the point being, this results in cheaper battery costs for you and I, and with a battery that's going to last longer. Nice. So, our second massive point that the battery report highlighted in where the battery industry is going is the use of lithium iron phosphate batteries. Of course, with China leading the way in batteries in general, they're leading the way in lithium iron phosphate manufacturing too. And this is the go-to chemistry for our BESS, isn't it? All home energy storage pretty much is lithium iron phosphate. If you've been watching my channel for a while, you'll know that I've got two Tesla Model 3 batteries with LFP packs, 60 kilowatt hour packs for use in home energy storage. So we're currently hooked on next door's telephone line. It's not broken, there's no issue. He's just trying to work out, scratching his head on how we're going to move this forward. Both of these packs contain cells which are produced by cattle. You've guessed it, China. But we are seeing more and more China-produced electric vehicles using LFP lithium iron phosphate batteries. While not as energy dense, they can handle thousands of cycles and are much cheaper to produce. In fact, I and the Volta Foundation report expects over the next few years we'll see more of an uptake in Europe of the smaller Chinese electric vehicles. And since these vehicles are produced to a price, they are likely to be LFP vehicles. Sometimes I get a little bit frustrated with the EV industry, seeming to move quite slowly. Now I understand that manufacturers are cautious of jumping in with a brand new range of electric cars because they don't know how many people are going to purchase them, but we're seeing battery development with EV prices coming down, and we're seeing battery energy storage systems reducing the price per kilowatt too, meaning more and more of us are likely to have some form of batteries in our life. There is so much about this report that I just don't have the time to cover in this video, but one subject that comes up in the comments section in a lot of my videos is safety of batteries. People have this idea that batteries are just dangerous, forgetting that they pump a gas into their homes and literally drive around with a flammable liquid that turns to gas very easily. But just focusing on the BESS, largely that uses the safer LFP technology. Just look at how the incidents, and generally we are talking fire and explosion, have reduced over the years. Now, this information would come as a huge surprise to some. As someone who clearly feels that electric vehicle batteries should have a second life, this is a good step in the right direction. And yes, the report did touch on the second life of EV batteries, repurposing EV batteries from vehicles into static energy storage systems. There are a lot of players around the world, some humongous companies like Nissan, Kia or Audi, and some much smaller. I've managed to have conversations with one or two of these myself, but unfortunately I just cannot share that information with you. There's a lot that goes on behind the scenes progressing this industry. Now, if there are any battery manufacturers that would like me to bring along my camera and have a tour of their factory, my email is in the channel page somewhere below. Click on that, let me know. I'd like to do that on the channel. Anyway, so do you think that China has won? Is there any way for America and Europe to win? Is the battle over? Well, you can let me know your thoughts in the comments below. I'd really like to know as well whether you could see yourself driving a Chinese electric vehicle in, say, 5 years' time. You know, I actually think that I could see myself driving one. Right now, I'm quite liking the new Geely Verizon Supervan. Comes in a range of battery sizes with 228 horsepower. Until next time, Battery Man out. Let's fill my life up with more batteries.